RAID. The server hard disk is used to store critical data that is shared in the network environment. A technique known as RAID, redundant array of independent inexpensive disks, is used to boost disk reliability, thereby helping to minimize data errors and prevent the loss and/or destruction of data. RAID guarantees a high level of reliability by storing error-correcting codes on the disk together with the data. It also provides a low-cost solution, since it is deployed over a number of small and inexpensive disks. Here, we will look at the basic RAID 0, RAID 1, and RAID 5 formats. RAID 0. The technique of splitting a volume of data into smaller parts that are stored in sequence across multiple disks is known as striping. The RAID 0 format is used for simultaneous input and output from individual disks via striping. RAID 0 enables rapid access but does not provide a recovery function in the event of failure. 2. RAID 1. RAID 1 employs the technique known as mirroring, where the same data is stored on two separate disks. This means that if one disk fails, the data can be obtained from the other disk without causing disruption to ongoing operations. 3. RAID 5. Data is divided into blocks and distributed across multiple disks via striping. Parity data for error detection is also calculated and stored for selected block units. This ensures that data can be restored in the event of a disk failure, thus providing a high level of reliability. The minimum configuration is 3 disks. Each block uses 2 disks for data storage and 1 for parity data. Evaluation of system performance. Performance evaluation indexes. A computer system cannot be easily evaluated. The purpose of use and form, the system configuration and processing content all have to be considered. However, there are several indexes for judging computer system performance. In addition, there are not only calculated indexes. The ease of use and quality of the user interface also need to be considered. Throughput. Throughput is the amount of work volume that a system can process per time unit. The larger this value is, the better the performance. 2. Turnaround time and response time. The time that elapses after a processing request has been sent to the system until a final result is gotten. The smaller the value, the better the performance. In batch processing, the turnaround time is the time from when a job is put in until all of the results are gotten. Response time in online processing is the time from when data is input until the processing begins. CPU performance indexes. MIPS, million instructions per second. The number of instructions that can be executed by the CPU in 1 second expressed in millions. Megaflops, million floating point operations per second. The number of floating point operations the CPU can execute in 1 second expressed in millions. Overhead. The operating system uses system resources. There are times when the system uses these resources for control and management. When it does this, it cannot give time to jobs or data processing. This amount of time, or the ratio of it, is called overhead. For the user, this time is unproductive time. The smaller the overhead, the better. Five, reliability and serviceability. Reliability is stable operation without breakdowns. In order to improve reliability, efforts to prevent trouble from happening are needed. If trouble occurs, fast repair is necessary. This is serviceability. 6. Ease of use, quality of the user interface. Whether or not the user is provided with an easy-to-use environment is an important measurement. An easy-to-use environment improves productivity and processing reliability.